A disease is known to be present in 2% of the population. A test is developed to help determine whether or not someone has the disease. So given that a person has the disease, the test is positive and it has a probability of 0.95, meaning 95%. Given that the person does not have the disease, the test is positive, that means false positive, with a probability of 0.03 or 3%. So information in the tree diagram. So what's basically happening over here? So whether a person has the disease or the person does not have the disease. So that's the first thing. So the probability that the person has the disease is 2%, so 0.23. That automatically means that 80% of the people do not have the disease, so that is going to be 1 minus 0.02 or 0.8. So that is the first concept. So disease or not disease. So that's the yes no concept of tree diagram. Now if the person has a disease and the test that they do for the disease, it can be true positive or it could be a false positive. So let me write true positive and false positive. Again, if the person does not have the disease, it can again be true positive or false positive. So that means it's the tree diagram follows the structure of yes no yes no. So this information is given that the person has the disease. Actually this is the exact type of model that actual scientists use. So the probability that the person is going to have positive is 95%. So 0.95% that a person has a disease and the test shows a true positive is 95%. So the probability that a person has a disease but the disease they show that he doesn't have the disease is 0.05%. So let me just write true and false. That would be better, meaning positive or negative. So the probability that the person does not have the disease but the test shows that he has the disease, so the test shows that he has the disease, so that is going to be 3%, and there's a 90% chance that the test would do that. Any test kit has that. There's a high chance of showing positive if the person has the disease, but there is a low chance of showing positive even if the person does not have the disease. Similarly, there is a low chance of showing the person does not have the disease even though the person has the disease. That's how it works. That's how many test kits work. So now the first question is question number A. Represent this information in the tree diagram. And then in question number B, a person is randomly selected from the population and tested for disease. Find the probability that the person will have a positive test. So positive test means positive for disease. So probability of positive. So we know there are two permutation over here. One permutation is that the person has the disease and the person shows that the test is positive that he has the disease. So 0.02 and 0.95. So that is the probability that the person has the disease and the test also shows that he has the disease. Or the other permutation is the person does not have the disease but the test still shows that he has the disease, meaning a false positive. So that is going to be the total probability that the person is going to test for positive, 0.043. Actually this is 4%. So the probability of being positive for this disease is 4%. Now the next question is a doctor is randomly selects a person from the population and tests him for the disease given that the test is positive. So what basically means is the total probability is that the person has the disease and that is 0.043. Whenever it is given, whenever some information is given, we have to write this down. This is the total probability now, 0.043, and we have to find the probability that the person does not have the disease. So does not have the disease means does not have the disease but still tests positive. So that is going to be 0.8 multiplied by 0.03. So given that the test is positive, find the probability that the person does not have the disease but shows positive. So that means here the event is going to be 0.8 into 0.03 and that probability is 0.558. Now question number D is interesting. So we just found out that there is a 55.8% chance. If you just convert this into, that's more than half of the people who are testing positive even though they do not have the disease. So there is a 55.8% chance that a person who does not have the disease is showing that the person is testing for positive given that the test is positive. That's pretty high probability. So let's comment on the suitability of this test. So the test is not suitable since a person can have a high chance of testing positive for the disease even though the person is not infected. So that's why this test is not very useful.